If I roll a die like this 100 times, then each of those 100 times I'm going to get a different sample mean. The distribution of these means are pictured on your screen right now. What is the expected value and the variance of this distribution? Well, in this video, we're going to use our rules for means and variances to derive the expected value and variance of this distribution. You'll see on the screen we have Rule 1 and Rule 2 for expected values. How can we use these rules to derive the expected value of the sample mean? Well, the expected value of the sample mean for the 100 rolls is equal to x1 plus x2 plus x100 divided by 100, and that's simply equal to the expected value of x1 over 100 plus x2 over 100 plus x100 over 100. Now I can use Rule 2 to bring the expected value through. So this is going to use Rule 2. So that's the expected value of x1 over 100 plus the expected value of x2 over 100 plus the expected value of x100 divided by 100. Now I can use Rule 1 to bring the fraction 1 over 100 outside the expected value sign. So that's Rule 1 with a equal to 0 and b equal to 1 over 100. That's 1 over 100 times the expected value of x1 plus 1 over 100 times the expected value of x2 plus 1 over 100 times the expected value of x100. Well, just rearranging this, this is 1 over 100 times the expected value of x1 plus the expected value of x2 plus the expected value of x100. Now the expected value of the value on any one roll is equal to 3.5. We derived that in a previous video. So the expected value of any x is just equal to 3.5. So we can use that in here. So that's 1 over 100 times 3.5 plus 3.5 plus 3.5. And this is 3.5 added up 100 times. So that's 100 times, which is just 1 over 100 times 100 times 3.5, which is just 3.5. And now notice that this is actually equal to just the expected value of x. And now we have the expected value of the sample mean for this distribution. Now let's calculate the variance of the sample mean. So the variance of x bar is equal to the variance of x1 plus x2 plus x100, the value on the 100th roll, divided by 100. Well, using Rule 1 with a equal to 0 and b equal to 1 over 100, we can pull out 1 over 100 out of the variance. So Rule 1 with a equal to 0 and b equal to 1 over 100, 1 over 100 squared times the variance of x1 plus x2 plus x100, the value on the 100th roll. Now, the value on each roll are statistically independent of each other. So now we can use Rule 2 to bring the variance through the summation. So this is going to be equal. So now we use Rule 2. Since x1, x2, all the values of the 100 rolls are independent. So now it's going to be 1 over 100 squared times the variance of x1 plus the variance of x2 plus the variance of the x100. but the variance on each roll is the same. And we worked that out in another video to be 2.92. So the variance of any individual x, I'll just write that up here, is equal to 2.92. So now this is 1 over 100 squared times 2.92 plus 2.92 plus 2.92. It's 2.92 100 times. So that's 100 times, and this is equal to 1 over 100 squared times 100 times 2.92, which is just 2.92 divided by 100, which is also just equal to the variance of any individual roll divided by 100. So now we have the variance of the distribution of the sample mean. Now we can picture the expected value and variance on a graph of the distribution of the sample mean. So remember that the expected value of x bar that we derived just before was equal to 3.5, and the variance of x bar is equal to 2.92 over 100. That means that the standard deviation of x bar is equal to the square root of 2.92 divided by 100, which is 0.17. Statisticians also often use the standard deviation instead of the variance to describe the average deviation from the mean. So let's picture it on this graph. So in the middle, we have the expected value, which is 3.5, and then one standard deviation in the positive direction from the expected value is 3.5 plus 0.17, which is 3.67, and one standard deviation below the expected value of the distribution is 3.33. And notice that the distance from here to here and here to here are both 0.17. In this video, we've derived the expected value and variance of the sample mean. Later on, we'll work a lot with the sample mean of data, and these results will be important to us.